For decades, scientists have searched for evidence of life on Mars, investigating its soil, atmosphere, and ancient water systems. Why are we so obsessed with this red planet? Why not Jupiter, or Venus, or even Mercury? Well, of all the planets in our solar system, Mars holds a unique place in our collective imagination. It's the planet most like our own, with polar ice caps, canyons, and volcanoes. But more importantly, it's the planet that holds the greatest promise of answering one of humanity's oldest questions: are we alone in the universe? Let's explore what's been discovered so far, and what it could mean for the possibility of extraterrestrial life. You know, folks, when we look up at Mars in the night sky, we see a cold, dry, and seemingly barren world. It appears as a small, reddish dot, a distant neighbor in our solar system that has long captured human imagination. From ancient civilizations to modern-day scientists, Mars has always been a source of wonder and curiosity. But don't let that fool you. Billions of years ago, Mars might have been a very different place. Imagine a world with a thicker atmosphere, where the climate was warm enough to support liquid water on its surface. This ancient Mars could have been a planet teeming with rivers, lakes, and perhaps even vast oceans. Evidence suggests that liquid water, a key ingredient for life as we know it, once flowed freely on the Martian surface. Scientists have found signs of ancient river valleys, lake beds, and mineral deposits that form in the presence of water. These discoveries paint a picture of a planet that was once much more Earth-like. We're talking rivers, lakes, maybe even a vast ocean covering the northern hemisphere. This ocean could have been as large as the Arctic Ocean on Earth, providing a potential habitat for life. The idea of a once-blue Mars is both fascinating and tantalizing. And where there's water, there's a good chance there might have been life. Water is essential for all known forms of life, and its presence on ancient Mars raises the possibility that the planet could have supported microbial life forms. Now, how do we know this? Well, our robotic explorers on Mars, like the Curiosity and Perseverance rovers, have sent back some pretty compelling evidence. These rovers are equipped with advanced scientific instruments designed to analyze the Martian surface and search for signs of past life. They've found telltale geological formations that could only have been carved by flowing water. These formations include ancient river channels, deltas, and lake beds, all of which suggest that water once played a significant role in shaping the Martian landscape. We're talking ancient riverbeds, sedimentary deposits, and minerals that form in the presence of water. These findings provide strong evidence that Mars was once a much wetter and potentially habitable planet. It's like looking at the geological fingerprints of a once wet world. Each discovery adds a piece to the puzzle, helping us understand the history of water on Mars and its potential to support life. But that's not all. We've also found organic molecules in the Martian soil. These molecules are the building blocks of life, containing carbon and other elements essential for living organisms. These are the building blocks of life as we know it. Their presence on Mars suggests that the planet had the necessary ingredients for life to potentially develop. Now, before you get too excited, organic molecules can be created by processes that don't involve life. They can form through chemical reactions in the absence of biological activity. But their presence on Mars is still incredibly intriguing. It raises the possibility that life could have existed on the planet in the past, or that it might even exist today in some hidden subsurface environment. It's like finding the ingredients for a cake, even if we haven't found the oven yet. We have the components, but we still need to understand how they might have come together to create life. And then there are the methane spikes. Methane is a gas that can be produced by living organisms, and its presence on Mars is particularly intriguing. Methane is a gas that can be produced by living organisms, and our telescopes and orbiting spacecraft have detected these spikes in the Martian atmosphere. These spikes are seasonal, suggesting a dynamic process at work. Now, these spikes could be caused by geological processes, but they could also be a sign of microbial life breathing beneath the surface. The exact source of the methane remains a mystery, but it adds another layer of intrigue to our quest for life on Mars. It's like Mars is sending us little puffs of smoke signals, and we're trying to figure out if there's a fire down there. Each discovery brings us one step closer to answering the age-old question, are we alone in the universe? So we've got evidence of past liquid water, organic molecules, and methane spikes. Taken together, these discoveries make Mars a very strong candidate for past or even present microbial life. Think about it. If life could arise on Earth, why not on Mars, especially when it was a warmer and wetter place? And even if life is no longer present on the surface, it's possible that microbial life could still exist underground, where it's protected from the harsh radiation and frigid temperatures. Now I know what you're thinking. Neil, why haven't we found any actual Martians yet? Well, finding life on another planet, even microbial life, is incredibly difficult. It's like looking for a needle in a cosmic haystack. But we're getting closer. Future missions to Mars, like the European Space Agency's ExoMars rover and NASA's Mars Sample Return mission, are specifically designed to search for signs of life. These missions will carry advanced instruments that can analyze Martian soil and rocks in unprecedented detail, looking for biosignatures, which are chemical or physical signs that can only be produced by life. We're talking about things like specific ratios of isotopes, complex organic molecules, or even fossilized microbes. It's like being a cosmic detective, piecing together the clues to see if life ever existed on our red neighbor. Chapter 3: Life Underground. A Martian safe haven? Let's face it, the surface of Mars is not exactly a hospitable place. The landscape is dusty, barren, and devoid of any visible signs of life. The atmosphere is thin, and the temperatures can plummet to extremely frigid levels. It's cold, dry, and bombarded by radiation. The lack of a protective magnetic field means that harmful cosmic rays constantly hit the surface. But what about underground? Could life exist beneath the surface, where it's protected from the harsh conditions above? The idea isn't as far-fetched as it might seem. Beneath the Martian crust, there could be environments that are much more stable and conducive to life. Well, here on Earth we found life thriving in some pretty extreme environments. From boiling hot springs to the dark depths of the ocean, life has a way of adapting and surviving. We're talking about extremophiles, organisms that can survive in boiling hot springs, acidic lakes, and even the crushing pressures of the deep ocean. These organisms have evolved to thrive where most life would perish. And even the crushing pressures of the deep ocean. These environments are incredibly hostile, yet life finds a way to not just survive, but to flourish. These extremophiles show us that life is incredibly resilient and can adapt to some pretty extreme conditions. Their existence expands our understanding of where life can thrive. So it's not a stretch to imagine that similar life forms could exist beneath the Martian surface, perhaps in underground aquifers or hydrothermal vents. These environments could provide the necessary conditions for life to exist. Perhaps in underground aquifers or hydrothermal vents. These hidden reservoirs could be teeming with microbial life, shielded from the harsh surface conditions. In fact, some scientists believe that if life ever existed on Mars, it's more likely to be found underground than on the surface. The subsurface could offer a stable environment where life could have persisted for millions of years. It's more likely to be found underground than on the surface. The underground layers of Mars might hold the key to discovering extraterrestrial life, and there's some tantalizing evidence to support this idea. Data from Mars rovers and orbiters have hinted at the presence of subsurface water and other conditions that could support life. Remember those methane spikes I mentioned earlier? These spikes have been detected in the Martian atmosphere and have puzzled scientists for years. Well, one possible explanation is that they're being produced by methanogenic organisms, which are microorganisms that produce methane as a byproduct of their metabolism. These organisms could be living deep underground, which are microorganisms that produce methane as a byproduct of their metabolism. These tiny life forms could be thriving in hidden pockets beneath the Martian surface. These methanogens could be living in underground aquifers, releasing methane into the atmosphere through cracks and fissures. This process could explain the periodic spikes in methane levels detected on Mars. Releasing methane into the atmosphere through cracks and fissures. It's like Mars is burping out little clues about the life that might be hiding beneath its surface. These clues are tantalizing hints that we might be on the verge of discovering something truly extraordinary. It's like Mars is burping out little clues about the life that might be hiding beneath its surface. The search for life on Mars continues, and with each new discovery we get one step closer to answering the age-old question, are we alone in the universe? Chapter 4. First Contact. What happens if we find Martian life? Imagine the headlines. Scientists confirm life on Mars. The world would be abuzz with excitement and curiosity. News outlets would scramble to cover every detail, and social media would explode with theories and speculations. The discovery of Martian microbes, even simple single-celled organisms, would be one of the most profound scientific discoveries of all time. It would revolutionize our understanding of biology and the potential for life elsewhere in the universe. It would tell us that we are not alone in the universe, that life is not a fluke confined to our pale blue dot. It would change everything. Our perspective on our place in the cosmos would be forever altered. But finding life on Mars wouldn't just be a scientific breakthrough, it would also have profound philosophical and ethical implications. We would need to consider the moral responsibilities that come with such a discovery. We would have to grapple with the fact that we are not the only living things in the cosmos, that our place in the universe is not unique. This realization would challenge long-held beliefs and prompt deep reflection. It would force us to confront our own assumptions about life, intelligence, and our place in the grand scheme of things. We would need to rethink our definitions and expectations of what life can be, and it would raise a whole host of new questions. How did life arise on Mars? What conditions allowed it to thrive? Could similar conditions exist elsewhere in the universe? How did life arise on Mars? Was it an independent genesis, or did it share a common origin with life on Earth? Is it related to life on Earth? Could there have been a transfer of life between the two planets, perhaps via meteorites? What are the ethical implications of exploring a planet that harbors life? Should we prioritize the protection of Martian ecosystems over our scientific curiosity? These are questions that would occupy scientists, philosophers, and theologians for generations to come. The debate would be intense and multifaceted, touching on science, ethics, and even spirituality. But before we get ahead of ourselves, we need to proceed with caution. The potential for contamination is a serious concern. If there is life on Mars, we need to make sure we don't contaminate it with our own microbes. This is crucial to preserving the integrity of any Martian ecosystems. That's why missions to Mars are subject to strict planetary protection protocols. These measures are designed to prevent any cross-contamination that could jeopardize our findings. We need to be careful explorers, respectful of the potential life that we might encounter. Our approach must be one of humility and responsibility. The discovery of life on Mars would be a momentous occasion, a paradigm shift in our understanding of the universe and our place in it. It would be a milestone in human history. It would be a discovery that would ignite our imaginations and inspire generations to come. The possibilities it would open up are endless. So, the next time you look up at the red planet in the night sky, remember that it might not be as barren as it seems. It could be teeming with life, waiting to be discovered. It might just be hiding the greatest secret in the solar system, a secret that could change everything we know about life and the universe. Outro Mars, a new frontier in the search for life. The discoveries of water, organic molecules, and methane make Mars one of the best places to look for alien life. It's like the universe has given us a treasure map, and we're following the clues, getting closer and closer to the prize. With new missions and advanced technology, we might be closer than ever to answering one of humanity's biggest questions. Are we alone in the universe? The answer to that question, whatever it may be, will have profound implications for our understanding of life, the universe, and everything. So, stay tuned, folks. The next chapter in the Mars story is about to be written, and it promises to be the most exciting one yet.